In Chapter 24, Paired Samples and Blocks, we're going to be looking at what a treatment does to a certain person's score before and after treatment. Now, this is quite similar to what we did back in Chapter 23, when we had two separate groups that were each generating their own mean, and we were looking at the difference in their means. This time, each person in our study or experiment is going to have a before and after score, theoretically with a treatment applied in between. And what we're going to look to see is their before score about the same or higher or lower than their before score? So for that reason, we call this a mean of differences. Each person is going to generate a difference after the treatment is applied, and we're going to look to see, is the average of those differences equal to 0, in which case the treatment didn't work, or are we going to see that the treatment did have an effect and the differences are either greater than, less than, or just not equal to 0? Well, in order to do this, of course, we do need some data. And so what we did here is I had 13 students try a word search twice. They first did the word search without a word bank, and they had 7 minutes, and we found out how many words they each found. After that, we gave them an equally difficult word search, but this time with a word bank. And again, found out how many words they found in 7 minutes. So let's see, where is that data? I know that data is around here. There it is. There it is. All right. So if we take a look at this data here, you see that right here, we have what happened without the word bank. They had an average of 23.5 words without the word bank. And then we gave them a word bank, and it appears like their average went up by about 4 words or so. Yeah, that looks about right. What's interesting here is we don't care about either one of these columns. What we really care about is the difference between the columns. Now, of course, if we look at the first subject here, they went from 18 words to 19 words, which is, of course, a difference of 1 word. All right? What happened with the second person? Well, clearly they went up by what looks like 3 words. And if I can get the spreadsheet to show that for us, maybe I'll get that done here. Maybe. Well, I'll tell you what, I'll just drag them all down. Sure enough, that was 3 words, like we said. This person went up by 8 words, and so on and so on. And you can see that overall, they did go up by 4.15 words on average. And there's our standard deviation. Now, what are we going to do with these data? Well, what I want you to do with these data is copy all of those differences into these boxes here. And then we'll go ahead and analyze them. So here we are back in the notes, and I hope that you've written down your differences on the paper here. I haven't done it here in these notes, but I do have it on my paper, so we are running in the same field here. Now, we have this new variable called d. And d is going to be very important when we're talking about the means of differences, because d actually does represent the difference. Now, it's important that we state which way this difference is looking. So we could say this is the difference between those with the word bank, and we'll say that, with the word bank, minus those without the word bank. And so what we're hoping is that the difference between these actually does end up being greater than 0, if we think the word bank actually helps. So what is our null hypothesis here? Since we're dealing with t-tests, our parameter is still going to be mu to represent the mean, but what we're looking at here is the mean of differences. So I'm going to write a mu subscript of d to represent the differences, and I'm going to assume that the word bank doesn't help at all. Remember, our null hypothesis is always that our treatment doesn't work, that everything is 0 and, all that good stuff. Now, our alternate hypothesis, though, that's going to be where we believe that the mean of the differences is actually going to be positive. We believe that the word bank is actually going to help students get more words. So that's why that's going to be my alternative hypothesis. Think of it as saying essentially that with the word bank is going to be more words than without. And of course, that's going to give us a difference greater than 0. Now, there are a few conditions we need to check. Of course, we need to make sure that the data is paired. So to do that, is it the same students before and after? And of course, in this case, it is. So I'll say same students with the word bank as the ones without the word bank. So we're dealing with the same students here. So our paired data is checked. Is it random? Well, when I look at the words up here, it doesn't look like they said one way or the other. So we can go ahead and just assume it's random. Hopefully it actually is. Independence is something very important that we need to look at here, but it's not independence between the two groups because it's actually the same people who are doing it before and after. So the independence that we need to look at here is each student being independent. All right? Does that seem like that's the case here? Does it seem like each student is independent of the next? Does one student affect the next? And what I'm going to say here is no, each student probably is independent. So we're okay with that. The 10% condition is very important when we're looking at studies. But since this is an experiment, we don't really need the 10% condition. And furthermore, since we've already shown that each student is independent of each other, we don't really need the 10% condition. We can let that one go. Sometimes we need it, sometimes we don't. As far as nearly normal, I do highly suggest that you run all of these differences through your calculator and make sure that your graph does end up nearly normal. Now, I did this earlier, and if these are my x and y axes, then what I'm going to say is I ended up with a graph that looked kind of like this. There were 3 bars that were all about the same. It was kind of a tall bar here, and then it kind of phased out like that. Now, is this nearly normal? Well, it is unimodal. That we definitely have going for us. It is unimodal. Is it approximately symmetric? Well, that could be up for debate, but I'm going to go ahead and just say that it is. And so we did reach the nearly normal condition. What kind of inference test are we going to use on this? Even though it seems like we have 2 samples, remember that all we're really looking at are these differences up here. So this is actually going to be a 1 sample t-test, and what I'm actually going to call it is a 1 sample paired t-test. And I'm calling it paired because the differences are a before and after or with the word bank without. So I will call this a 1 sample paired t-test. All right, our conditions are met. We can continue on with this. Let's take a look at the mechanics. All right, so let's jump into the mechanics here. I know that the calculator will do most of this work for you, of course, but I think it's still important that we take a look at this and see how it all develops. Of course, if we just run through this top row here, we do know that we had 13 students in our sample. Remember that finding the degrees of freedom when we had a 2 sample t-test was crazy. There was that nasty formula that we're never going to use. The calculator told us everything, but here, this is quite simple again since it's a 1 sample t-test. The degrees of freedom are just n minus 1. So we have 12 degrees of freedom. As far as our mean difference, of course, we saw that on the spreadsheet, or you can use your 1var stats in your calculator to find that. The standard deviation of those differences in that sample, again, was on the spreadsheet or in the calculator, 3.44. And with that, we're good to take a look at this. Now, this t-score formula is not as bad as the 2 sample t-score formula. In fact, it's not really bad at all. On the top, we're just looking at the difference between what we found and what we thought we were, maybe going to find. So, of course, our mean difference here was 4.15. We already wrote that down. And if you look back at our null hypothesis, we did hypothesize that the difference would be 0. So that's the difference between our sample and our parameter. Now, if we take a look at the bottom, this is a pretty standard formula for the standard error of our sample. Of course, S sub D, we have that right here. That was 3.44. And we just divide that by the square root of the sample size. And this will give us our standard error. Now, just continuing this out, of course, the numerator is just going to be 4.15. That's just going to be the difference. The standard error, though, here, if you go ahead and calculate this out on your calculator, I did it earlier, and I got about 0.9 0.954. That is our standard error. Of course, if you divide those, you'll get our t-score, and our t-score here is about 4.349. Again, try this in your calculator, see if that's the same thing you get. I've certainly made mistakes before, but I hope this is right now. All right, so we're going to look at what's the probability that our t-score with 12 degrees of freedom is higher than 4.349. Well, how do you do that? Well, just remember what this really is a not a normal CDF, but you want to use the t-CDF in your calculator if you want to calculate it that way. And if you do this, what you're going to find is what looks to be a p-value of greater than 1. I got a p-value of 4 point something, but of course that's ridiculous. Look at the entire number. You'll notice that times 10 to the negative fourth at the end, which actually tells me that my p-value is going to be something along this magnitude. Now, what can we say about that p-value? Well, what we can say is that p-value, 0.000473, that is certainly far less than our alpha level of any reasonable alpha level, really. We'll say 5%. So since our p-value is so low, we are going to reject our null hypothesis. There's nothing new to that, of course. But what does this mean in context of the problem? Well, remember that our null hypothesis was that there was going to be no difference between using the word bank or not. We're rejecting that. We're throwing that out the window. In fact, what we can say now is we have evidence. We do have evidence of not just an increase in the number of words we find, but we have evidence of a significant, remember our p-value is very low, so we have evidence of a significant increase. And this is an increase in the number of words with the word bank, and I'm going to abbreviate word bank, versus the words without a word bank. So according to our data here, we find that having a word bank does seem to allow students to find more words in those 7 minutes. Now, it also asks us to find and interpret a 90% confidence interval. This interval will, of course, hopefully with 90% confident, it will capture the difference in the number of words with a word bank versus the number of words without a word bank. Of course, your calculator will do this if you use the t-interval function. But what I'm going to do here is I'm going to say, well, the difference that we found was 4.15. That's the difference we found. And what we're going to do is we're going to add and subtract our critical value, which is our t-star with 12 degrees of freedom, multiplied by our standard error. Now, our standard error we already found to be 0.954. We found that up here, of course. So the only thing we need to do is find that t-star. And to find that t-star, what I suggest you to do in your calculator, if you have an TI-84 or higher at least, is to use inft. Now be very careful when you use inft. You don't want to inft the 10%. Remember, you want to inft half of that. All right? So what we should end up with here is 4.15 plus or minus. If you do the correct inft, and I do want you to pause this video and try it on your own. But if you get the same thing I did, that critical value was 1.782. That's what I found. And then, of course, multiply that by our standard error. And what I'm going to end up with is a confidence interval that stretches from 2.44 all the way up to 5.84. And again, remember what that confidence interval means. What this actually does is tries to capture the actual difference between the number of words found with a word bank and the number of words found without the word bank. Clearly, 0 is not in our confidence interval, and that's good. That shows that we certainly did reject the null and said that 0 is not, according to our data, what we believe to be the truth. So, what we've done here with this Chapter 24 example problem is we have looked at a mean of differences. A mean of differences. All right? we found that in this particular example, we ran a bunch of students through a word search without a word bank and then with a word bank. We collected our differences, all right? We didn't care what happened before or after. We looked at the differences and found that that mean difference was in fact greater than 0. It does appear that students find more words with the word bank. And then, of course, just to build on that, we said, well, how big is that difference? And that's what we found here with our confidence interval. The true difference between words with the word bank and without the word bank is captured somewhere between 2.4 and 5.8. So, most of the problems that we're going to do are of this variety. Of course, they can always throw different things at you. But of course, we have some homework problems, and we'll take a look at a few previously used AP free response questions dealing with a one sample t-test for the mean of differences. Of course, don't confuse that with what we did in chapter 23. And as you go through the homework and go through these previously used AP problems, just keep these notes handy, continue to use them. They're a great model, and good luck with your work.